Okay, so today we begin with actual physics. So before this class is over, after 3 years, we will have seen from the very big through to the very small. So we're going to learn about electrons and how they move around circuits to create electricity, and we're going to learn about planets going around in orbits and asteroids and stars. But that all starts with one simple concept, which is motion. Almost everything is in constant motion, from atoms vibrating inside a molecule to the planets orbiting around the sun. So we need to study motion in order to understand the behavior of objects here on Earth. So we're going to start with the easiest type of motion, which is linear motion. So what that means is objects moving in a straight line. So an example of that could be, we have a ball, and the ball is rolling to the right. And it has its speed, and it's going to travel a distance, and it's going to take some time doing so. And we're going to study how those three things are related. But we're only going to care about the movement or the motion of the ball in one direction. That's what we're going to start with. There are no forces yet, so we don't care about how the ball started moving. We don't care about who pushed it or who kicked it or why it's moving, but we care about how it's moving and what it's going to do while it moves. So in order to start this, I'm going to do a quick parenthesis called significant figures in order to teach you something about numbers that is very important in physics. So significant figures is basically how many important numbers you give when you give an answer. So many times you put numbers into the calculator and you're going to get really long numbers. For example, if you put the division 10 divided by 6, you're going to get 1.666666667, depending on how many numbers fit in your calculator. And many times students think that every single one of those numbers is important. So they put every single number. And they end up having some really long numbers, and that's not really necessary. The number of significant figures, or the number of digits that we care about, generally is not more than 3. Maybe sometimes 4, maybe sometimes 2. But we never have to put 10 digits of a number to be accurate. So significant figures is how many important digits there are in a number. So if we have, for example, the number 0.1, we have one important digit. One digit gives us information, which is the 1. The 0 says nothing. If we have the number 1, it's also one significant figure. Also 10, or 100, or 1,000. All of these give us one digit of information, the 1. The zeros don't really tell us anything about the size, just about the magnitude. When we learned about scientific notation, we learned about the exponents. These zeros to the right or the zeros to the left are the exponent, but the number that goes before the exponent, this digit here, is the one that we call a significant figure. So these are all examples of one significant figure. Now what would two significant figures look like? Well, in this number, adding another number after the 1, maybe 1, 2. Or in this case, 1.2. In this case, that would be 12. In this case, 120. And in this case, 1,200. No matter how many zeros or how big the number is, the significant figures is how many of the figures are important, basically are different than 0. So we can do that with 3 also. Let's say 0.121 or 1.21 or 12.1 or 121 or 1,210. All of these have 3 significant figures. I think you get the point, right? So generally what we do is that the number of significant figures that are in the original number that we put in our operation, in our calculator, is the same number of significant figures that we're going to use for the answer. So let's do an example. Let's say I ask you to divide 81 into 26. So this number has two significant figures, the 8 and the 1, and this one has also two significant figures, the 2 and the 6. So you put it in your calculator, you say 81 over 26, and you get 3.1153844615. And what many students will do is write that whole giant number. So 3.11538461. But I don't care about all of these numbers, and neither should you. So what we want is, because the original numbers had two significant figures, our answer should also have two significant figures. So basically we care about this 3 and we care about this 1, but we don't care about anything other than that. So we erase every other number. And that's the answer that I want from you. Yeah? Sometimes it happens that the number after is, for example, an 8. What if this had been the answer? Well, then you always need to round. 3.18 is not closer to 3.1 than to 3.2. It's closer to 3.2. So you would take this 8 and make the 1, become a 2. And you would give the answer as 3.2. Let's do this other example. So instead of 81, we have 8,126. So I'm going to get the same answer, but move to the right. So let me do it in the calculator. 8,100 divided by 26 gives me 311.538 and the rest of the numbers. So again, this number, even though it has more zeros, is just like this example. It still has two significant figures because the rest are zeros. So in our answer, we're still looking for two significant figures. So we care about the 3 and we care about the 1, but we care about nothing else. So we erase everything after the point, but our answer was 311 point something. So our answer, you can't put the decimal here and change the answer to a 31, because that would definitely change the value. So the closest number that we have is 310. We don't care about the 1, it's too much information, so we change that 1 to a 0, and we get the number 310. So we need to keep the decimal point where it is, but we give less information. The same thing would happen if this were an 8, just like in the previous example. If this were an 8, then we have 318 point something. The closest number with two significant figures is 320. So we don't put 310 anymore, we would put 320. We round with this 8 to make this 1 a 2 and get 320. So always when you're doing multiplications or divisions, take into account the number of significant figures, the numbers you're using, and put the same number of significant figures in your answer. Never put the whole answer from the calculator.